We are in some weird times in the world right now. We have various states and countries in various stages of reopening and venturing out from. I don't need my headphones on for this. I don't know why I have my headphones on for that. We are in some weird times in the world right now. We have various states and countries in various stages of reopening and venturing out from this corona pandemic, the lockdown that has been occurring. And just when things started to calm down, or so they seemed, um, May 25th happened. Now, May 25th, Memorial Day, the tragic killing of George Floyd took place. Now, I don't want this to be an in-depth conversation and talk about this situation. Honestly, at this point, is still unfolding. But I do want to say this on behalf of myself, Aaron, and Josh. How George Floyd died was tragic, and all those involved should face appropriate repercussions. His death was something where justice needs to be served against every person involved in his death. A death that was needless, tragic, and could have been prevented. That being said, there are many aspects of this which may not have been revealed to the public yet. We might learn some things over the coming days. And I'm not saying that to justify what the cop did or anyone else. I'm just saying there might be more parts of this that we'll see, and it might even cause more outrage, to be honest, going forward. And right now, I think the pressure for justice needs to continue. However, however, justice does not involve destruction of property. I'm glad to see that there are a lot of protests going on, which are peaceful. They are being done according to law. They're following local ordinances. They're following the directions the police are giving. And for a good chunk, that's happening. You're seeing when riots are occurring, people coming out the next day to help clean up the neighborhood. You're seeing those people. And that's a good thing. Now, there's always going to be bad apples. Even in the peaceful protest group, they're going to cause issues. You're seeing mostly at night the quote unquote bad apples come forward, causing destruction to property, to businesses, the looting, the burning of buildings, the all that. They're doing a lot and they're causing problems. And what I think we need to be aware of, and what is in the news a lot right now, is that it is potential, verified, not verified, but it is potential that some of these people that are causing these problems are coming in from out of town, out of state. They have their own agenda to serve, and they're taking advantage of this tension that's going on in the U.S. We should not associate what is happening in those times necessarily with the peaceful protesters. That honestly is not honoring the memory of Floyd properly. And that is honestly not how I believe he would want to be remembered, based upon, and I base that upon, the actions that he took while he was alive. And these are well documented. So I just wanted to get that out of the way. But now let's talk about our topic at hand. It's now the end of May when I'm recording this, and life is starting to return to normal around at least a good chunk of the United States. There's still some areas like New York and Chicago and Milwaukee proper that are still going to be locked down for a little while because they do have a large corona COVID spread. But for most everyone else, life is starting to get back to normal, at least a little bit. Businesses are opening back up, restaurants are happening, people are going out to eat. True, these restaurants and that they may be at reduced capacity, but at least they're still opening. They're getting people back to a sense of normalcy. Now, people are still wearing masks around stores when they go out, but the number seems to be going down on an almost daily basis. In fact, I was out today And I would say in the past week, it used to be something around the lines of like 60, 70% of the people I would see outside would be wearing masks. But today, when I went to the store to pick up something, maybe 10%. It was a big difference in the number of people that were and were not wearing masks over the course of just 1 week, and I think some of that is just that release, that tension that things are starting to open up and go back to normal, so people are being a little less scared. But I digress. Now that life is starting to return to normal, I got interested in something. So, I have a little more time now to research things because I'm not sitting there trying to read on the latest what's happening with COVID and Corona every day, kinda trying to see what's going on. But something caught my eye a little while ago. Now, here's the thing that caught my eye. At the start of this pandemic, we were told through a model that if we did nothing, so if we did no social distancing, we did nothing to help contain the spread, then in the United States, we'd have about up to, not about, up to 2.2 million people in the United States who would die from COVID 19. And the same model also predicted that over in the UK, there would be about 500,000, up to 500,000, that would potentially die. Again, this is if nothing happened, no social distancing, nothing. And to be fair, this led to leaders around the world creating these policies that we did see in place while we were under COVID quarantine at home. You know, safer at home, stay home, save lives. Those slogans that you've been hearing these past few months, and this concept that in order to stop the spread or slow the spread, because we had to reduce the curve, slow the curve, that we need to stay at home. And yeah. Yeah, okay, that makes sense. We had no idea what was going on with the virus. We didn't know how lethal it was. We didn't know, especially at the start, what were all the symptoms. We didn't know how it spread really. We had an idea. We didn't know how infectious it was. We didn't know anything that. So at that point, we were relying on some models and we were relying on, scientists around the world saying, hey, here's some ideas on what we can do. And it was appropriate. It was appropriate for governments to say, you know what, right now we need to, out of precaution, take some steps. Canceling social gatherings, canceling large groups of people, saying, hey, if you can work from home, work from home. That's logical. I have no qualms about how this started. But as the data started rolling in and we started seeing projected numbers versus actual numbers, something caught my eye. There was a big difference between the two. And at first I was like, okay, yeah, that could be one thing because, this is a new virus again. So since it's a new virus, we have a set of assumptions. Now we have some data, we have to change those assumptions and that model changes. That's how it's supposed to work. And that's, what they were saying they were doing on the back end. And I was like, okay, so at first it's going to be way off. But as we go through everything, it should get better. But those predictions didn't get better. They didn't get closer in line with what we were seeing. That started to make me go, interesting. Because even with all of the precautions we took, social distancing, canceling everything, these models were still predicting a large death rate. And like I said, it made me start to go, So I looked into a little bit more. So for those of you who are unavailable on my background, I'm an IT professional. I work in IT. My primary job is automation and scripting. Scripting is just programming, not necessarily like C or Fortran or R or something like that. It's I work specifically in PowerShell. Okay, 99.9999999% of my professional life, I write code in PowerShell, mostly for Windows-based systems, but for Mac and Linux too. I do have some experience with that. Um, I've spoken at conferences on PowerShell. I've spoken at user groups, and I've passed community exams saying I know what I'm doing. Now, I'm not doing this to toot my own horn. I'm not saying, look at me, I am perfection incarnate with PowerShell. No, there are people out there that know way crap ton more than me. There are people that are still learning and maybe one day will surpass me, and that is fine. I am fine with that. What I'm doing here is I'm saying, look, here's my credentials. Because someone will ultimately take what I'm saying here and say, well, how can this person speak to what's going on? How can we trust them? And those are good questions to ask. When someone is given an opinion, just because they are given an opinion does not mean that their opinion is valid. The person giving the opinion should have some bona fides, some credentials, some skin in the game, some experience with what they are talking about in order for their opinion to be taken as authoritative. Now, everyone can have an opinion on everything, but if it's not an authoritative opinion, maybe you need to be a little skeptical of it. So that's the only reason I go over, that programming is something I do. Now, I don't have particular experience, a ton of experience in C or Fortran, but I know enough to be able to read the code. And I was taught in college how to read the overall structure and syntax of a program, even if I don't know the language itself, and be able to at least get the big picture pieces out of it and recognize when there are bad things going on in the code. So the code. The code used to generate the model has been used multiple times, or at least been based on this code, has been used multiple times with various diseases in the past, with various, I don't even want to use the word success rates, failures. So let's take a look at some of those here. So again, same code, same person who ran the code, who wrote the code. And these were the predictions they were given. So during 2001, I just graduated high school at that time. There was an outbreak of foot and mouth disease over in the UK. I wasn't aware of this at this time. So the model was used to justify the death and culling, as they call it. If you're a farmer, you probably understand that better than I do, of about at least 6 million sheep and cattle. Let that number sink in for a second. 6 million because of this model. The model also predicted up to 150,000 people would die. Ultimately, the death rate was less than 200 people. Oh, but the model saved us because we killed these sheep and cattle. Let's continue. In 2002, it was predicted that up to 50,000 people would die from mad cow disease in the UK alone. As of the time of this recording, there are 117 deaths. In 2005, it was predicted that up to 150 million people worldwide would die from the bird flu. In the end, between the years of 2003 and 2009, so this includes data before the model was fed the data to make the assumptions on how many people would die, 282 people died worldwide. In 2009, in the reasonable worst case scenario, that's in quotes, for the swine flu death was around 65,000 deaths in the UK. There were only 457. Now, I'm not saying this to make light of the fact that a low number of people died. Well, I am using that to make light of, not make light of, but point out that number of people died. Because any death is too much. So I'm not saying, he predicted 50,000, we had 200. That's good that 200 people died. No, it's good that only 200 people died. It sucks that at least one died from the disease. But that is the nature of living. We're going to have diseases, natural disasters, threats that come up that are going to cause issues for us. Our lives are never, never, ever going to be free of danger. It's what happens. But I bring that up to show the discrepancy between these models. Now, one would expect that the models and the code that the models, were generated from would be refined over time. The 2001 foot and mouth disease, count that as your version 1.0 code. Your model and your data are going to be off. That's to be expected. But by 2009, your accuracy should be a little bit better. Bugs should be fixed, issues should be resolved, and the modeling should be refined even more. Yes, I understand this is not financial modeling. I understand that there's a difference between financial modeling where things kind of move in one direction, really only, you inject $150 million here. What happens? How did the markets react? I get that. And when you're dealing with diseases, people, we don't do things logically. We will move however we want to move. I want to go to Target today. I'll go to Target. But the model didn't predict that. So, you know, there's a little more complexity, and I get that. And that's why I said over that time, it should have been refined more and more to account for some of the findings that they've had over the time. But it didn't. And why is that? Well, there's a couple big red flags with the code. Um, and this is from things that I reviewed on the code. This is things from others that reviewed on the code. So let's take a look at it. Well, I'm not going to actually show on the screen because it would probably bore the bejesus out of everyone here. But let's take a look at the issues in the code on why it's causing issues. One of the first things that honestly blew my mind about this code is that, and it's documented right on the GitHub README page for this code, is that the code is stochastic. Now, what does that mean? It's really because programmers try to think that they're smarter than everyone else. So apparently that we have to create new words to mean everyday things. It means randomly determined. The code at its very core is randomly determined. That is, it has a random probability distribution or pattern that may be analyzed statistically, but may not be predicted precisely. And that's the core of the code. So that's my first big red flag. Now, why is it a red flag? It's a red flag because it is impossible to run what's called unit tests against this code. Now, what is a unit test? A unit test is honestly, in the simple terms, a way to test the code with you give it specific results and you get the same output. So, in other words, if I had a function, a piece of code, I give it the number 1. Every time I give it the number 1, that test should come back with a value of 6 each time. This is considered standard. This is something that was established back in even the 70s, I believe, that where you test each little piece of code to make sure that the changes that you're introducing into the code don't cause a regression, a bug, an error into the code. So if I give it the number 1 and I get the number 4 instead, that tells me something in the code changed where I'm not getting the results I expect. And therefore I need to go look at it and fix those bugs. The unit tests are done on individual segments, like I said, of the code, as well as the overall code itself. And this can take some time, especially, I was reading the notes for this particular program for modeling this data for the United Kingdom. They recommend at least 128 gigs of RAM. That's actually a large amount of RAM. Not many consumer computers have that. So your average Joe probably isn't going and running these simulations on their own computer. But at least it's out there in the open source world now where people can do this. So, if I provide a file into the code, I should get the same results every time, no matter what computer I run it on, no matter how many times I run it, no matter the time of the day, and no matter who's logged in running it. Same input, same output all the time. If it does that, that's considered a successful pass. And then that is good. In my line of work, code can't be moved into production until it passed that simple test. Because if it doesn't pass that simple test, we got an issue with the code that we need to fix because that's going to cause errors and that's going to cause incorrect data. And that could be problematic on many levels. Now, here's the thing with this code. This code, given the same input, will give you a different answer each time. That is a big red flag for concern. It will never pass it. Well, let me rephrase that. It never passed unit tests. Now, thankfully, since kind of the fear came up of, what was in the code, how was it making the miles and that, the code was given to Microsoft and a couple other companies, and they refined it some and have worked on some of the bugs. So now there's a switch on the code, and a switch is essentially an option. You're giving the program an option. So there's now a switch there that you provide that switch, and you are supposed to get the same results provided you give the same inputs. Now, reading through the issue log for the code, this isn't 100% yet, but at least it's in the right direction. So that way, unit tests going forward can be run. But why did it take until people started getting outraged over the course of the fact that they had no insight into how the code was run, what the results were, and what the assumptions were? And there was no trust. And the fact that we're seeing that there was no unit test being run, because it would have been impossible to run unit tests on it if it was generating new results every single time. Now, and here's the other thing, the code is hardware dependent. That's a problem. Now, when I say it's hardware dependent, what I mean is the code in its original form, and here's the thing, we will never see the original form of the code. Only places like Microsoft that have seen the original code. We've seen the cleaned up version, but it's better than nothing at this point. But the original code, up until recently even, has a little stipulation on how you run it. It has to be run with the same number of threads. So if you run on a different processor type, let's say you took it from an i7 with hyperthreading and moved it to a computer with an i5 without hyperthreading, you get different numbers of threads, different number of processors, virtual and physical. It will give you different results even if you give it the same input data. So again, here we have that issue, or it's you have to make sure all the conditions are right, otherwise your unit tests are going to fail. Now, I could understand this back in the day, around 2001, when dual core computers were still honestly a relatively new thing. So I can understand that the original code from 2001 on having it. By the time you got to 2009, 2015, 2020, 2, 4, 6, 8, 10, 12, heck, 64 core consumer processors are a thing. And on the server side, the professional side, where you would run this sort of modeling, multiple CPU computers as well as multiple core CPUs has been a thing a lot longer than on the consumer side. And as the years have gone on, the tooling to be able to write code that works properly in a multi-threaded environment has gotten easier to use. There is no excuse for not leveraging these tools to be able to generate the proper runs. And that's concerning. Now, the next issue is more, I guess you could say, personal opinion, coding style thing. But the fact that it was called out by the other professionals as well is also kind of concerning. So, the original code, again, which no one outside Microsoft and a few others have seen, was essentially one file that was like 15,000 lines long. And the big key part there is all one file. In coding, there's this concept of separation of duties. Each function, each duty. So where you're writing to a file, whether you are updating a database, getting that great GIF from the web. Each of those is its own function, and each of those functions should be its own separate file. This makes debugging, testing, and authoring way easier across the board. Instead of having to load up one large 15,000 line file, searching through it for the exact portion on where I want to update the code and where I want to do things, I go, oh, I know the exact file I need to edit. And it maybe it's a couple hundred lines at most, but they're usually a lot smaller than that. Maybe I've seen files as small as 5 lines because that function does one thing, it does it well, and it moves on. And that's how code should be separated. Each function does one thing, it does it actually exceptionally well, and moves the data on to the next piece. And that next piece is controlled by the user who's writing, the main code, which ties all the functions together. That's neither relevant for here nor there right now because you don't need to know how to do coding yourself. But what you do need to know is that the code that was provided does not follow these coding best standards. Again, I can understand if this was the 2001 version of the code that was like this when it was first being built, when these standards really weren't kind of enforced across the industry, when things were just being developed. But there have been years where this is kept this format. And that's not excusable. Now, the next strike comes directly from the code itself. Well, no one is providing a direct answer at this point. Based on the information available within the code itself, it looks like the code was machine translated from Fortran to C. Now, for non-programmers, you're like, okay, translated, you might think of like translating English to Spanish. It's kind of the same, but not exactly. And if you're going between languages like English to Spanish, as long as you get the general gist of what's going on, you're usually pretty good. If you ask someone, where is the bathroom? And you can kind of get a general gist of, right to left, right. You don't need to know, go left past the empty table, then turn right by the picture of their mother, and then turn left by, the swinging door. As long as you can kind of get the gist of it, you're usually pretty good. There are some exceptions to that. But when programming, if you're using machine translation to translate from one computer language to another, you introduce new errors into the system. And I say that because it's not a perfect one-to-one translation. There are functions that may exist, a functionality, functions, processes, methods that may exist in the original coding language that don't exist in the new one, or vice versa. So when you do this, you introduce the possibility for new bugs to occur. And if we don't have unit testing to be able to test the code, that's a red flag right there for me. But this continues on even further. There are still remnants of function calls in the code which look very Fortran-y. And there are also very outdated C function calls as well. So that tells me that the code hasn't been updated over the years to use the latest and greatest version of C, which usually compiles faster, runs faster, and leaner, as well as fixes previous bugs. In fact, there is a rounding error. There is a rounding error in the code. It's in the issue tracker for the project where they talk about if they don't add point 0.1 to a value, they're not getting the expected value because the function that's being used in the code is not the correct function that should be used. So therefore, they have to introduce, I guess you could say, correctional values to correct and get the values that they want to get. And of course, this introduces this whole other concept then of what does that do for this wide other range of values that may be used instead of 0. That was particularly this case that they were dealing with. What happens then? And if we don't have unit testing available because of the randomness of the code, there's no way to validate that everything works. So I'm glad that now the code is open source, because now that it's open source, we'll have more people who can view the code, who can audit the code, who can provide fixes for the code and discuss various components of the code as they go on. And I think that will ultimately make it a better program as time goes on, and we'll be able to make the model more and more tight, more and more accurate. Where you're thinking, okay, so he doesn't trust the code. That's fair. I don't. Um, at least the version that was run that generated the original 2.2 million and 500,000 deaths scenario. Now that it's in open source land, I'm trusting it a little bit more, especially as more people are digging into it, seeing the idiosyncrasies of the code, as well as making bug fixes. And that's great. Now, I'm not the only one who thinks this is an issue. David Richards, who is the co-founder of WANDisco, and WANDisco is a company that makes software for a living and over distributed computer networks. So they understand the concepts of being able to write code across many computer threads, cores, and processors. So they understand that, what the complexities are and everything. Well, David was recently interviewed and about this code, and he got a chance to look at the original code. Lucky man. But according to David, the code was, and I quote, "a buggy mess that looks more like a bowl of angel hair pasta than a finely tuned piece of programming." And he even added, "In our commercial reality, we would fire anyone for developing code like this, and any business that relied on it to produce software for sale would likely go bust." He also brings up the concern, like I did, that testing would be difficult on the original code. And he says testing allows for guarantees, is what you do on a conveyor belt in a car factory. Each and every component is tested for integrity in order to pass strict quality control. Now, another issue with the code. There's so many issues. It really blows my mind that this code was used to uh, to inform, to form so many policies around the world. So another issue with this code, in the base assumptions of the code, was that the code was originally written to handle flu viruses, not coronaviruses. Coronaviruses and flu viruses spread differently, have a different infectivity rate, and have different ways of transmission. So the value that we got, the 2.2 million, is essentially based on data entered into a model based on the flu. And you kind of wonder why people said, oh, this is just like the flu. In a way, the data simulations, at least the original ones, kind of were like that. And that's a problem. Using data simulations and assumptions from one type of virus for another produces results that are unexpected and unreliable, as we definitely see in this. And the fact that this was not disclosed when the models were first run and the data was first published is terrifying and scary. And that should have been one of the forefront pieces published right out there. It said, this was written on the assumption that this behaves like a flu virus, not a coronavirus. Again, it goes back to how the viruses act. Now, I'm not saying we should get rid of the code base fully and start over. No. The fact that the code is now on GitHub, can be audited, updated, changed in public view with a full audit history is a good thing. More people are able to review the code, provide updates, feedback, push back on issues with testing and reproducibility of the results. In fact, now the code is being done in open source. Like I said before, it's possible it only gets more accurate as time goes on. And this is a good thing for all involved. This is a good thing for the university where the code came from. This is a good thing for Neil Ferguson because it makes the model, the code, more reliable, more robust, and the estimates and the policies then derived from it can be trusted more. And you don't have people then questioning, like we do now, why we are kind of locked up when the model that generated it has so many issues. This has taught me something, and I think it teaches everyone here. We need to question things before they start to go scary. Now, I'm not saying go into a conspiratorial place. I'm not saying that this was done on purpose to lock people down. I'm not saying to say, well, I don't believe it, and therefore do whatever you want. I'm saying ask questions. Make assumptions that the person does have good intentions, but ask. You should ask questions about the data being used to make policies. And people who make policies should be given that data out, saying, based on the data, here's the data, here's how the assumptions were made, here's the model that was used. Based on this data, these are the policies we're making. Now, not everyone can read through the code. Not everyone can read through the assumptions. Not everyone can read through data and fully understand it, but there are people out there who can. And like I said before, it is okay to dissent with the majority when you need to look at the data and figure out, is this data, is this model, is this prediction accurate or not? So I'm saying be skeptical, not conspiratorial. Because when data is used to upend millions of people's lives, their daily lives, their jobs, their money, their mental health, we should at least take a look at how that model is generated, the assumptions used, and the quality of code that was used to produce it.